Good morning, good afternoon, good evening, wherever you may be in this part of the world. Welcome to my presentation in a very interesting topic titled Project Lifecycle of an EPC. EPC means engineering, procurement, and construction projects in the oil and gas industry. My name is John Kweku Amotu. I'm a professional electrical engineer for 30 years and I'm based in the United States. Next is the outline of my presentation, and basically I will talk about the initiation of projects, planning and execution of the projects, construction phase, and pre-commissioning, commissioning, and startup, and closure. Basically, that is all about the project life cycle. So this slide shows us just a flowchart of the cycle of a project. As you can see over here, it starts with the initiation of the project, and I'll go much into details what the initiation of the project life cycle is about, and basically that's the project conceptualization stage, and it moves to the planning stage, execution. Usually the planning and execution are kind of tied together, and in between that you need to basically track, monitor, and implement corrective actions. So that is the controlling part of managing projects. Then the last piece is basically the closure part. That is when pre-commissioning, commissioning, startup, and then all takes place. Next slide, basically projects, title project initiation, and that is the conceptualization phase of every project. And this stage, that is where all the processes that are involved in the project is defined and implemented to meet the objectives of the projects. There are defined processes and objectives, and how it's going to be implemented to meet the objectives of the project. And usually the time duration is about 16 to 24 weeks, depending on the size of the projects. So it is during this stage that conceptualization of the project takes place on high level. And for certain projects, mega projects, big projects, usually project sponsor is selected, and that's more of a VP level, vice president level. So he basically is going to sponsor the projects, provided they provide everything that is needed for the project. It is at this stage that the project is defined. Then all the stakeholders on the client side or the owner side is basically they come together and they are selected. And like I said, it is at this stage that the conceptual design or preliminary design is basically performed, and is basically performed to achieve the operational parameters that is desired. And the goal is basically to maximize profitability. So they will put in the conceptual design that will be able to achieve those operational parameters. Next is they develop a business case justification, and usually they put out a report to justify the projects, the need of the projects, and the benefits if the projects is implemented. It is at this stage that the initial scope, I would say, just a preliminary scope, is also initiated. Then a ballpark estimate of the financial, how much the project is going to cost. It's not going to be all that accurate, but at least it's an estimate where contingencies are put into it, or cushions are put into it to account for changes along the line, or unexpected costs that will creep in along the line. Then a timeline for the completion of the project, the start of the project, estimated start of the project, and how long the project is going to take for it to be completed and for startup to take place. Next is the feasibility. As you basically conceptualize a project and define a project, right, you also want to check the feasibility of the project. As much as you are basically, aiming for profitability, you also want to make sure that that project is feasible. And you check the operational feasibility. So that is why you tie in all the stakeholders from the operation side. And in terms of scheduling, such a project is that feasible within that time constraints that you plan on implementing that project. Are you going to get the required outages, in terms of interconnecting other, let's say, subsea projects? Are you going to get an outage from other transmission network that basically ties into that substation? So that piece is basically the feasibility part. Then economic feasibility, in terms of a return of investment. How viable is that project in terms of economics, cost and return on investment? How much you put in and how much you're going to get from it, as time progresses. Next is project risk analysis. It is at this stage that all the risks are identified and the risks are analyzed and evaluated. And basically a tentative mitigation is put into place. And even then, you have to go above and beyond and make sure that the tentative mitigation plans is going to work. Next is feasibility of access roads. Where are you going to have the project? Are you going to have access roads, or you have to put in your own access roads? So that itself introduces additional cost, and that has to be accounted for. And also the logistics for the construction. Are you going to have a place to store the items that you're going to use for construction? Now let's talk about the risk management part of the projects. So I've identified a few, but it could be more than that. First one is material delivery risk, where you're going to source the material, basically the delivery on time of the material. So that also has to be factored into place. Then the economic viability of the project, like I indicated, how much you're putting in to basically install this project and how much you're gonna get out of it, and also inflation cost, as inflation. So you also have to basically analyze all those elements and find out whether it is very viable in terms of the economic piece of it. Then the operation piece is when you identify all the risks that are associated with integrating such a project into your existing operation system. Then the finance part, that is basically getting the amount of capex, capital expenditure. Also the return on investment, how much you're going to get out of your investment. After the initiation of the projects, as the first stage of the project life cycle of an EPC project, the next stage is the project planning and execution stage, and this is the second stage. And the first part of the second stage is the front-end engineering design. And, this can be done by an EPC contractor or an engineering contractor. The time duration is usually about 24 to 36 weeks. Yeah, this is a little bit longer duration. So once the project manager is selected during the initiation stage of the project, the first stage of the project, now it is incumbent upon the engineering manager to select all his various disciplines for the projects. So let's walk through the typical disciplines that the project manager will select. The project manager will select the electrical project engineer, the mechanical project engineer, the instrument project engineer, and sometimes even the instrument project engineer. He might select two or more, you know, one for the field instruments and one for the SCADA or the DCS. He will select the civil engineer or the structural engineer or architectural engineer. Then he will select the environmental engineer. Then he will select the fire protection engineer and the piping engineer. Next is the simulation studies, and this is part of the planning process. So an initial simulation studies is performed based on the conceptual one-line design that has been put in place. So let's walk through a typical simulation studies. If it is an electrical engineering project, let's take, for example, a subsea project. So load flow studies will perform basically to your power flow, your active and reactive power flow, and voltage profiles across each bus will also be determined and basically evaluated within to meet the criteria of voltage fluctuation. Next is the short circuit studies. Basically, this is done to make sure that the equipment that is going to be installed can meet the equipment selection based on short circuit duty. That is the duty of the short circuit studies of the equipment to be able to meet what has been obtained from the studies. Next is a motor starting analysis. Starting a motor basically involves a draw of reactive power from the system, and that, as you know, starting a motor takes about 10 to 12 times the nominal rating current of the motor. So that itself results in an approx dip in voltage. So motor starting analysis studies is performed if you have large motors, especially for an industrial facility that has very large motors. Basically, you want to perform this motor starting analysis, that is starting the largest motors with the other motors running, and to see the voltage dips on the buses, and basically evaluating to make sure that it is meeting the requirement. Next is transient and dynamic studies. Basically, this is when a short circuit is implemented and to simulate basically clearing of a fault and the transients that is associated before the faults are cleared. Next is installation coordination studies. This is very important, where basically short time over voltage studies, transient over voltage studies, fast front over voltage studies are performed. And the goal is to make sure that the insulation, the basic insulation level that is that needs to be selected for this equipment, and also the selection of surge arresters the substation is adequate to mitigate over voltage condition that can basically stress the insulation and can cause equipment failure. It is at this stage that the process for each discipline, I indicated, we have many disciplines for a mega project. We have electrical piece, the mechanical piece, instrument piece, the civil piece, architectural piece, environmental piece, fire protection piece, piping engineer piece. So you need to basically create a process flow diagram for each discipline, and PNID documents for each discipline. And most of you that don't know what a PNID is, piping instrumentation diagram. It's a process flow diagram that shows you the connection of piping and instrumentation. Next is the data sheet for each process, right? Each discipline. Yeah, as you perform the initial simulation studies, like I indicated, let's take, for example, the electrical substation piece where load flow is performed, right? So load flow, there's going to be simulation report and data sheets. Short circuit steps, there's going to be data sheets for each equipment. Installation coordination studies. There's going to be data sheets for each equipment. So these data sheets can be obtained for all the equipment. And now let's talk about, we've talked about the electrical piece. Let's talk about mechanical piece and the static. For a static process, you can have tanks, you can have heat exchangers. You can also obtain data sheets for rotating process equipment, that is pumps, turbines, motors, and compressors. Then also for power transformers, switchgears, high voltage circuit breakers, and for data for instrumentation process. So you obtain all these data sheets after you perform the initial simulation steps for each discipline. And I just gave you a typical example of what is done in the electrical piece, and that is the simulation studies in load flow, short circuit simulation studies, where basically you perform the short circuit simulation studies to see all the short circuit flow on each bus to the connected equipment to be able to select the fault duty, right? The symmetrical or asymmetrical fault duty of the equipment that you are selecting. For example, you have a switchgear, right, that is connected to a bus. So after simulation, you find out the symmetrical, the asymmetrical short circuit current that your initial simulation studies gives you from your report and from your data sheets. Then after that, you use that to be able to select your symmetrical and asymmetrical duty of the switchgear that you consider for your equipment selection to be manufactured. So this is an example of how this is done. So the mechanical side, they also have their softwares that they utilize for simulation. So they also do that and spit out their data sheets. That helps basically in the equipment selection and further design down the line. Then each discipline identify the basis of the design, right? For instance, you are designing a power transformer, right? Basically, there has to be a basis for that design. The switchgear, there has to be a basis. High voltage circuit breakers, there has to be a basis. Okay, so all of these are part of substation. So there has to be a basis for the need of that substation. So it is the electrical discipline that basically identifies and drafts the basis of the designs and implements their own internal design. And for rotating equipment like motors, this is also done. The civil engineering discipline also identifies all the major structures that needs to be put into place and implements their own design. Mechanical engineering disciplines also do the same thing for the mechanical equipment and the instrument type. Also does it for the field instrumentations and the DCS equipment. And the piping team also do that for all the design of the pipe routes. So it is at this stage, having gotten all the data sheets, right, and having put into place just a initial design, then you move on to your cost estimation part. And that is the capital expenditure. So that is when you start putting all the pieces on your cost estimation, right? And that is the CAPEX part. Then it is at this stage that you can also reach out to various vendors, right? Based on the data sheets that you have basically gotten out of your initial simulation softwares for all the disciplines that you have to firm up the cost estimate. Okay, so let's say you're putting the cost estimation into place, and you're able to, based on the data sheet, you're able to identify that with a power transformer. Right? So that is when you reach out to a vendor to give you a proposal on the rating of that power transformer. So based on the cost estimate that the vendor gives you, then you can plug in it back into your cost estimation sheet to firm up your cost estimates. The next piece is the material takeoff. If you have a mega project that has a lot of piping, a lot of concrete, so Then the discipline team starts that material takeoff, because that itself involves a lot of work. As part of the front-end engineering design, the feed stage, these are all the deliverables. So the front-end engineering has an input, right? Has an input stage that comes from the initiation stage of information data that is gathered from the initiation stage. And the output of the feed stage is what is given to the client. And these are overall one-line diagrams, right? This is conceptualization of the one-line. Data sheets, reports. Reports are, simulation studies for various, all the disciplines. Project cost estimate, project procurement estimate, and the project schedule. So it is at this point that all this information that has been given to the client or the proponent, then the proponent goes to the next step of inviting bids. So what the proponent does is he puts a bid documentation together with all the specs, with all the requirements in a bid documentation, and invites various companies, engineering companies, EPC companies, to bid for this product. So after the bids are submitted, they perform commercial and technical bid evaluation based on certain list of criteria. A typical example of a criteria that has to be listed is the cost, the commercial piece, right? Then the technical piece, that is meeting what is in the specification, meeting it. Then also the safety piece and the experience of that EPC contractor having performed successfully on similar projects. Then the qualification of the EPC contractor, the skills that the EPC contractor has. Next stage is the award of bid and selection of the EPC contractor. So basically, this technical bid evaluation is performed, commercial bid evaluation is performed based on a list of criteria. Then, based on that, scores are assigned on that technical bid evaluation. Then the bid is awarded, and the EPC, successful EPC contractor is selected to move to the next stage of the project planning and execution, and that is detailed design engineering. Next is work breakdown structure. As I indicated that, during the detailed design engineering stage, right, we have different disciplines. We have process engineering, piping design, mechanical design, electrical design, civil and structural and architectural design, health and safety and environmental design. So each is going to have a typical work breakdown structure where under each discipline, all the tasks are broken, identified, and listed. And the required man hours and weights are assigned during the work breakdown structure for each discipline. This is done for detailed engineering design. Now let's talk about the deliverables of detailed design engineering. I've made mention about the process flow, how information flows from each stage. The initiation stage, where all the data, all the information is gathered, that becomes an output from the initiation stage that is fed as an input to the feed stage, front-end engineering design stage. Then the output of the front-end engineering design stage becomes an input to the detailed design engineering stage. Then the output of the detailed design engineering stage is what I have listed here on the slide. That is the one lines. So the one lines, that is listed here will be the one that is issued for construction. The final one lines, though it is subject to field markups. 3-line drawings, schematics and wiring, system studies report, data sheets, equipment selection list, piping and instrumentation diagram, bill of materials, sizing calculations, equipment layout, material takeoff. Then procedures are put into place for commissioning, for startup and operation. So this is going to be the output that is going to go to pre-commissioning, commissioning stage. So now let's talk about resource loading for the detailed design engineering. Right, there's something called resource loading that is basically implemented in the schedule based on the work breakdown structure. So you have different disciplines, right? So you have different design engineers that are going to do the work. So you have assigned man hours for each task that is going to be done and weights that are going to be assigned. So detailed design engineering usually does not have a high weight. Let me put it that way. It's more, construction that has a much higher weight. So this is a typical example of a schedule. As you can see over here, it has all the components, of detailed engineering design. And under detailed engineering design, you have the work breakdown structure under each discipline. And under each discipline, you have the identified task, right? So you have the dates that is supposed to start, the date that is supposed to finish, and also the milestones, and basically the months, month 1, month 2, all the way up to, let's say, month 24, that is supposed to complete the detailed design. Next, in terms of monitoring and control of planning and execution part of the project, right? We have curves and histograms that we utilize. Basically, we have a baseline that target that we're supposed to be, and we do the measuring of the actual, and basically we determine the delta or the gaps, and perform the required investigation, right? Why that delta, and what corrective actions that we can implement to basically meet the baseline. So the first one is the S-curve, as you might have heard about it. And basically, that basically tells you the percentage progress of the projects and the dates as it progresses. Next is the histogram that is based on man hours as the project progresses. So you have the baseline or the target and the actual that is measured. Next is the procurement piece, right? Okay, so this is still part of our planning and execution. Okay, so it is at this stage that your goal is basically to get the best material, the best equipment, and the best suppliers and the vendors at a very good price, right? Then you should have the financial plan in place to be able to implement that. Then you should have an approved vendor list, and usually your purchasing department has approved that vendor list. And sometimes you have these vendors that basically do not do well, and they are put on probation, and at times they are given action items for them to work on to improve their services to get back on the approved vendor list. Then you should also have a specification for each equipment. So let's talk about the process for procurement. First of all, it starts with a material requisition. That is basically your specification. And if you have a blanket purchase order, you can also utilize that. Then you request for quotation, right? Then basically the receipt of quotation. After receiving that, perform the technical bid evaluation and the commercial bid evaluation. Like I made mention that during the technical bid evaluation, that is when we come up with a list of criteria. Right, okay. So one of the some of the criteria are basically meeting what is listed in the specification. Right? Let's say for a power transformer, all the parameters that is listed in the specification, you evaluate with what you received on the receipt of quotation. Then the experience of the contractor is also another piece. Does the contractor have an experience implementing, executing such projects in the past? Then the safety piece is also a part. Does the contractor, based on past projects, have they implemented the required safety measures? Have they violated any safety measures? So this is a list of the criteria that you need to list and evaluate as you are performing the technical evaluation. And the commercial piece is basically the cost. You evaluate the cost based on an industry well-known estimate. If the EPC contractor is providing too high cost, then basically you take note of it. So scores are assigned up to each criteria. Then after that, the scores are total, and basically the best contractor, EPC contractor, or basically the best vendor is selected, and the purchase order is issued for them. Then once the vendor receives the purchase order, basically the vendor is going to send his drawings, documentation, technical data for review. So this itself also has a sequence. Basically, the vendor sends it to the client reviews it, has review comments. Review comments are sent back to the vendor. The vendor sometimes has to schedule meetings to discuss those comments until an agreement is reached, until those agreed comments are incorporated. Then basically the equipment based on the final drawings. The drawings definitely, and the technical data has to be finalized, all documentation has to be finalized on that. So next stage is basically after the design phase, right, with the vendor. Then basically the manufacturing starts. And during the manufacturing, you have an inspection, key witness stages. So this is when you have your inspectors, quality control. Some of these clients are high industry inspectors to do that piece for them. So these inspection points are identified during each part of each equipment. Right? This is part of our inspection testing plan that is listed for each equipment. So the customers are consultants, all customers are inspectors go to the facility to perform all the key witness and inspection that is supposed to be done for each equipment. So it reaches final assembly, right? Final assembly they have a key inspection and witness and factory acceptance testing is performed. All this has to be witnessed, and this is based on an ITP plan that is put together, inspection testing plan, and that inspection and testing plan is put together based on the specification and also industry standards and industry best practices. After the factory acceptance test, right, the equipment, the results are evaluated against acceptance criteria that is listed on the inspection and testing plan. Then, if the equipment successfully passes the fact test, it is then shipped to the site where the project is and put in storage. When it gets to the site, it has to be inspected upon receipt, right? Okay, so because let's take for instance an example for a power transformer. If let's say you have a 200 MVA power transformer that needs to be shipped, right? Before it is shipped, first of all, the oil is drained and put into gallons in the transformer. All the components, let's say the bushings, are dismantled and packaged nicely. The radiators are dismantled. The control cabinet is also dismantled. And all of these, this is the winding gauges, the OTI, the oil temperature indicator, the winding temperature indicator. All these components are removed and basically packaged together. Then also includes the manufacturer manuals, drawings. So all these has to be inspected, right, upon arrival at the construction site. So it is the discipline engineering that does that in the presence of the vendor's field personnel or construction personnel that has been sent to the site to support these inspections. So the goal is to make sure that during transportation, none of these components get damaged. As you know, like I indicated earlier, all these components of a typical transformer are all dismantled and packaged together, and the transformer oil is drained, and the transformer itself is filled with air. So before, and also transformers that weigh like more than 20 tons, they are fitted with impact recorders. And the impact recorders basically are able to basically record if there's any shipping damage to the power transformer. So when those impact recorders get to the construction site, they have to be removed and sent back to the vendor for analysis to make sure that the transformer wasn't damaged during shipping. Nonetheless, there's going to be other testing that is going to be done, and that is the site acceptance testing. Testing is done after installation, basically to confirm that the transformer didn't get damaged during transportation. Right? And let's talk about the typical site acceptance testing for a power transformer. So once the transformer gets to the site, all the inspection is done of all the components, everything is intact, and basically during the installation phase, all these components are put together. The bushes are installed, the control cabinets are put together, the OTI, the winding gauge, the transformer with conservators, all of those pieces are put together. And the ground connection, everything is connected. Then testing starts, right? Okay, so for a transformer like that, typical site acceptance testing is turns installation, turns ratio test. Okay, so why do we do a turns ratio test? Basically to make sure that none of the transformer windings are shorted, right? 10 to 10 shorts are shorted. Right? So all basically the transformer got damaged during transportation. Next is the insulation resistance testing, polarization index testing, just to make sure that when during transportation the transformer itself insulation system did not get contaminated. Next is the extension system. So basically, extension testing is done to make sure that there are no 10 to 10 shorts, no broken leads, and also no shorts connected to tap changers as well. Then we have the impedance testing. This is also done to make sure that the active component of the transformer is intact and all the winding arrangements is intact. Then you have the capacitance and tan delta. So the capacitance testing is also done to make sure that the active component and arrangement internally of the transformer are all intact, and also the insulation system is not contaminated and deteriorated. Then the tan delta is basically the condition of the insulation system. Next testing that is done for some of the transformers is sweep frequency response analysis. And during the factory acceptance testing stage at the factory, a baseline sweep frequency response analysis testing is done, and that becomes like a fingerprint for that throughout the whole life cycle of the transformer. So this testing is repeated in the field as part of the site tests, right? So this testing is done, and the charts is compared to what is obtained from the factory, just to make sure that no shipping damage is done to the transformer. So these are typical tests that are performed for the transformer as part of the site acceptance test, in addition to other functional testing that is done for all the auxiliary components of the transformer. Next is the construction phase, right? Okay, so let's take a scale back. I've talked about the initiation stage of the project as part of the project life cycle. I've talked about the front engineering design stage of the project in the detailed design engineering stage of the project, right? So the output of the detailed design engineering becomes an input into the construction stage, right? So during the construction stage, that is when mobilization is needed. All the contractor, does all the mobilization, and all the discipline engineers are, basically on site. And also a camp with accommodation. Sometimes, based on the remoteness of this project, it requires accommodation for the staff that are going to work on the project. Next, as you know, construction is all dependent on engineering and how good engineering piece and procurement piece of the project life cycle was done. So if the engineering and procurement piece of the project was done successfully, and also the factory acceptance testing of these equipment was done, and the testing results were good, then that helps with the construction piece. The construction piece can be divided into areas, packages, and different disciplines. Then this piece, the construction piece, is basically where the major equipment are stored. It requires manpower and resources and equipment, construction equipment. So this is a typical example of the work breakdown structure for the construction work. So as you can see over here, it's been broken down into different disciplines. That is how the work breakdown structure works. You have different disciplines, and under each discipline, you have, as you can see over here, right, you have a civil structure. So under civil structure, you have excavation, concrete works, and steel works. Then you have piping, you have underground, above ground. Then mechanical, you have static equipment, you have rotating equipment. In the electrical and instrument, you have cable laying and transmitters and gauges for instrumentation. Then pre-commissioning. This is the work breakdown structure for pre-commissioning and commissioning. Same thing. So this basically tells you how construction comes into play. Like I made mention that we have work breakdown structures, right? Basically, we have a schedule. The schedule basically consists of an input of the work breakdown structure and the tasks that are associated with the work breakdown structures. So you have resources that are that is the miles for the work, the weights, the costs. So like I indicated that construction piece of the weights that are assigned to construction piece carries a higher weight than the feed stage and detailed design stage. Next is typical resource loading, right? Like I indicated, as you can see over here, we have activities, right? We have different disciplines: construction, civil, structure, architecture, right? And this is the work breakdown structure. These are the weights that are assigned to each task that is being performed under each different work breakdown structure and each discipline. Next is project closure, right? Okay, so after construction installation, right, that is when the EPC contractor has to do something they call mechanical completion certification. Okay, so mechanical completion certification can be done in partial or in full. In full, when the whole mega project is done, or it can be done in partial as installation is completed, construction is completed based on systems, subsystems. Then basically mechanical completion certificates can be issued for that subsystem or for that system. Right? Okay, so that involves a lot of work. Basically, we have a checklist that we utilize, and this is done by joint team by the EPC contractor, the owner, the client, pre-commissioning team. And they use PNID drawings, electrical drawings, and also like I indicated, they have a punch list that they go through. And before that, basically the contractor does a point-to-point check let's say if you have a switch gear, right? After installation of the switch gear, they will do a point-to-point check to make sure that the switch gear is supposed to, all components of all elements of the switch gear is working as it's supposed to, based on the drawings, based on instruction manuals, based on the process diagrams. Then installation resistance testing of components that has to be tested. So this is all done before pre-commissioning starts. So pre-commissioning basically starts right after mechanical completion certificate is issued, right? Okay, so where a checklist is prepared, and you can utilize also this we have online databases that has templates of how pre-commissioning is done. And you also need this certification ready for commissioning status right after the mechanical completion certification. So until you receive a ready for commissioning status, you don't start pre-commissioning. So you need a mechanical completion certification and also toggling of the phase to ready for commissioning. So that is when pre-commissioning starts with a commissioning team. That is pre-commissioning manager, pre-commissioning engineers, health and safety engineers, proponents, maintenance organization, operation organization, etc. And sometimes, with vendors of each equipment, they are there for pre-commissioning as well. So let's talk about the typical task, things that are done during piping pre-commissioning. So, as you are doing the piping pre-commissioning, that is when flashing inside piping is done, where you have a lot of debris that have been lodged, especially some of them due to rusting, because some of these piping have been sitting in the yard for sometimes for so many years, so it might have some component of a little bit of initiation of rusting. So it needs to be flushed there. So at this time that flushing fluids are utilized to flush this piping to clean them and get them ready for use. Then also leak testing is done. So where these pipings are filled with fluids and basically leak check is performed. Then pressure testing. This piping should be able to handle the required pressure that it was designed to. So it's at this stage that pressure testing is done, and also flow tests. Basically the flow, we have flow gauges basically that are mounted at different stages of all this piping for this mega project, basically that measures the flow in all these instrumentation and gauges are checked based on the checklist and approach test. Then let's talk about what is done for motors. For motors, we'll have a bump test. You want to bump the motor to make sure that it is rotating in the right direction, and also phase test to make sure that the motor is wired as it's supposed to be, and basically its rotation is going to be in the right direction. Then also winding resistance testing is done just to make sure that all the connections are intact. There's no open circuits anywhere. There's no broken, no 10 to 10 short. Then insulation resistance test basically is done to make sure that there's no inherent contamination. Basically, during shipment, during installation, nothing is affecting another. Then no load on couple run. But this is when the motor is uncoupled. It's not connected to any load or any compressor in turbine, where basically the motor runs and basically all the parameters are monitored and basically taking notes to make sure that it is running as it's supposed to. Next, let's talk about pre-commissioning for a battery. Because as you can see, over here, for a substation, right, we can have different types of batteries. We can have the lead acid battery, and also the vented valve-regulated lead acid battery. Okay, so typical test that is done for batteries is a cycle test, right? Cycle test is basically where basically you charge, discharge, charge, discharge, charge, discharge. You can do it for about 3 to 4 times based on the manual of the vendor. And the goal is to make sure the charging capability of the battery charger, to make sure that it meets the requirement. Next is the load test, where basically the battery is connected to a load and basically let it discharge for a period of time to make sure that the discharge rate connected to the load is what it's supposed to. All the parameters are measured for each cell and for the whole battery cell. Next is a trick test, basically the ability for if the normal source it's basically is disconnected and basically the battery take over. Okay, that test has to be simulated to make sure that the battery will take over that load that is supposed to provide when it's needed. So let's talk about pre-commissioning for an electrical system. We can talk about power transformer, right? Okay, so for power transformer, where that's when we do the checking of the grounding and the body cable. Very, very important, because as the transformer is erected and basically bolted to the foundation, and the grounds are installed. Usually, you can have 2 grounds from each corner or 4 grounds, depending on the size of the ground, or depending on your internal procedure for guidance grounding transformers, bonding cable. Like you need to check to make sure that they are connected and intact. And also testing turns ratio. Remember, I made mention that turns ratio is done to make sure that there are no open circuits in the winding. There are no broken connections in the winding. And also insulation resistance. No, to check to make sure that your insulation system is intact against contamination. And after that, you do the polarization index testing. That is the 10-minute insulation resistance over the 1-minute insulation resistance. And basically you compare it with a criteria, and the list of criteria that we utilize for the polarization index. And typical for a new transformer like that, you're expecting the PI to be greater than 2.0. Next is your winding resistance. You do the winding resistance testing to make sure that there is no 10-to-10 short, no open connections, no broken connections. And there's a typical criteria that each phase shouldn't be more than 2%. Next is capacitance in turn delta. Right? So capacitance testing basically is to measure the arrangement of the active component in the insulation systems. Right? Okay, so the insulation system of the high voltage to ground, low voltage to ground, basically they have an inherent straight capacitance, and basically this capacitance is calculated, and that should be on the nameplate or the testing factory acceptance testing data sheet. So you do the capacitance testing and compare it with what is on the nameplate or what is in the factory acceptance testing to compare it to make sure that it shouldn't deviate more than 5%. If it deviates more than 5%, then basically you have a problem with basically the active component might have shifted during transportation. Then also the turn delta is basically the power factor. That basically measures the contamination of the oil system and the thermally upgraded paper insulation system. Next is extension testing, right? Okay, so basically extension testing is basically to test the 10-to-10 short open connections, and also shortening of the core and loosening of the insulation system of the core laminations. Next is the impedance testing. Impedance testing basically tests the active component of the core and the winding, and the arrangements of the winding system. Okay, so if there's any damage during shipping, basically you can find it from the change in impedance. So you compare the impedance that is measured with the nameplate impedance, and basically it should be more than plus or minus 7.5%. If the impedance is less than 10%, but if the impedance is more than 10%, then basically I think the delta shouldn't be more than plus or minus 10%. Next is then you have a protection. Basically what they put in all the logics, and also they perform protection settings for they put in all the protection settings to test the protection really for the power transformer, right, where they do primary and secondary injection to basically and the secondary injection they do it to check the pickup of the settings of the various power transformer protection elements, and also the timing of these settings. Then after that, they generate a punch list. Right? So if there's any deviation, if there's any gap that they encounter, they put it on the list and basically for it to be checked and basically corrected. These are some of the challenges to consider when you are doing pre-commissioning and commissioning. Right? Whilst you are doing all this, you're going to be on a time pressure, right? So you should be able to manage that pressure whilst you are working on performing pre-commissioning and commissioning, especially for projects that are being delayed due to delivery of equipment late, and also project schedule not following as it's supposed to do. So during commissioning, you'll be under that pressure to basically. So one of the things you want to do is basically do the right thing. Don't be under pressure and basically cut corners. The safety piece part of it is very important. Whilst you are performing pre-commissioning and commissioning, you want to do things the right way and follow all your safety measures that has been put into place, safety guidelines. Then you want to prepare a commissioning package, right? Okay, so commissioning packages basically comes from the mechanical completion stage, the construction stage. And these are basically rolled over into commissioning packages. Then you want to do your pre-commissioning and commissioning with high quality. Very, very important. Also, you want to incorporate collaboration with all stakeholders, all disciplines. Right? And also the documentation part of whilst you are doing the pre-commissioning is very, very important. The checklist, make sure that everything is documented. Then interface with the engineering team in different disciplines is also very important. Next, let's talk about commissioning. So commissioning basically starts after pre-commissioning, right? So commissioning is basically where you are moving from installation, construction. You've done pre-commissioning, and now you are ready to put their facility into commercial operation status. Okay, so this can be done by system or subsystem. Then you can have a hot commissioning, cold commissioning. Hot commissioning is basically when you have actual fluids in the pipeline. Cold commissioning is when you have cold fluids in the pipeline. Right? Okay, so as part of commissioning, you want to basically do a pre-startup safety review. Very, very important, right? Like I indicated, startup is basically you are checking and finalizing everything that has been done in construction, pre-commissioning, commissioning. Every work that has been done is complete, and basically the required safety review needs to be implemented. And the required safety verification is done during pre-startup safety review, and this can be done by systems or subsystems. So let's talk about the staffing, right? For commissioning. You need operations, you need maintenance, right? So maintenance operations, they are the ones that are going to use the facility. So you need to be part of the commissioning. You need emergency response, right? Because during commissioning, basically you are feeding this piping with the actual fluids. Basically, if anything goes wrong, you need to have an emergency response, and you have to have your emergency response team trained to be able to handle all this expectation. You also have to have a production planning. You also have to have a commissioning manager, different vendors, commissioning engineers, EHS engineers, quality engineers, QC, QA engineers. And so the things to consider is, like I indicated, your emergency response team has to be around. Your work permit system, very, very important. You need to, your work permit receiver has to be trained and know what you're supposed to do. And safety is very important. You need procedures and packages. So with that brings to the end my presentation. Thank you so much for your listening ears. And if you like it, select like in YouTube and select subscribe in YouTube. Thank you so much. Watch out for the next presentation. Thank you so much.